Today let's discuss the concept of lifetimes in Rust, which is a very important concept. And we'll start with a video which will take us through this lifetimes and scopes and things like that. So let's look at a very simple concept example first. The code a program first, because as they say, code is worth thousands of words. So let's see that. So we see that. Here we see let r, so we have a variable at function scope r, and we haven't even specified a value for that you might say, hey look, how can you, I thought you said that in Rust everything should be initialized. You non-initialized values um, are not allowed, but how can you can even compile this program? Well, think about it. True that r is not initialized, but we also don't use the value of r before initializing, so that's okay. Only constant only says that you can only use a value after it is initialized. It doesn't say you can't define a value without being initialized. So that's fine. Now here you see we have a variable in block scope x, but and then r is which is outside, which is from a bigger scope, is given made a reference to that x, and then the block is over, x is finished, but we continue to use r. Now what happens? Does this program compile? I would think not, considering how what a strict language it is. And it is true. It says x does not live long enough. Borrowed value does not live long enough. So the x is dropped here. Basically, think about in your if you're coming from C++ world, that is scoped variables where automatic memory management through scoping, in the sense that when a thing goes out of the scope you free it. So you see x dropped here at this point, at this, let's go do the line number. So the line number is very easy to do here. So okay, here you see the x dropped in the at line 7. Now when x is dropped at line 7, but on line 9 you try to use r after x was dropped. So that's why the compiler is telling you that borrowed value does not live long enough. So I guess this is a compiler's way of saying that, hey look, this, what are you trying to do? So either you take this guy x and make it live in the outer scope, then this program will obviously compile, but I'm not going to, you can do that on your own, but I guess very easy to see that why that should not be a problem. Now let's look at another example. In this case we use with non-primitive types like a string which lives on the heap rather than int or float or doubles that are copied. They have copy semantics. So here this we let's see what happens here. Can we compile this program? So if you see Rust C, now we got one more thing, missing lifetime specifier. What is that? This is our first introduction to in Rust, where the Rust compiler has used the word lifetime with us, and we are like staring at it. So what is that? We never heard of that. Missing lifetime specifier. I mean, we have never seen that concept in any other language, even in Python, even C++. So coming from the background of C, you might say that, hey, look, this is a strange beast, but what's going on here? He is saying, I'm expecting a named lifetime parameter. And it even tells you more help. It says this function's return type is a reference, but the signature does not say whether it is borrowed from X or Y. So the compiler cannot determine if given the references that are given to it, whether the borrowed reference or the returned reference will live long enough. So by looking at the program, it's okay right now. You might say that, hey, that should not have been a problem. But imagine a generalized scene where you really have these things living all over the place and you really don't know. And imagine the compiler, imagine that lifetime or this kind of checking is not there, and you return the just like on the basis of values here without any further logic, and you realize that, you know what, one of the arguments lives less, so it has a smaller lifetime, but you still return and the lifetime is over. So that is why he's saying you got to specify that in the very beginning. So here we see, first time we see a new syntax, and this is how you annotate a function with a lifetime. You're saying apostrophe is the syntax for that. So when you say you're saying this function is annotated with reference lifetime a, he takes a variable a or a reference in lifetime a, another reference in lifetime a, and returns a reference in lifetime a. So now you see it should be able to compile. Now if you do a rush C, and it compiles, see. So this is you got to annotate functions with lifetime annotations, the arguments and the return values before the function will compile. And now you might say that, but how, like I don't see the benefit of it. Now let's take another program where you will see the benefit of it. So this is instead of the longest we do a compare. This is the same thing. So here also there are actually annotations. So everything is annotated. So you see the function is annotated, arguments are annotated with lifetimes, and the return. It's saying I can, just by looking at the function signature, the compiler can say that as long as you specify the constraint that the lifetime um, of the return reference is at least minimum of the two lifetimes, or whatever, in this case the common lifetime of the arguments, where I'm okay. So you see this program of course will compile like the last one, but if you were to, how the lifetime can help us is, like if you were to take this guy and use this, let's move this answer. See, the x was in function scope, y was in block scope, and we use the return value from the we made the call inside the block scope. The return value, the answer, was used outside the block scope into the function scope. And now how we will realize that how lifetimes uses. See, we're saying cannot find value answer in this scope. So these annotations help the compiler determine that so if that this value is basically using something outside scope after it was no longer valid. And that compare, if you see the annotation, what will happen is there are two variables that are passed to you with different lifetimes. If you think about lifetime a, lifetime again, so he's saying in this case the concrete lifetime will be used of y, because you specify only a here, not b, right? So you will take the lesser of the two lifetimes as the value of a, and then you will assume that the return reference should be at least valid for the lifetime of that, so at least for the lifetime of y. That's why when we had this printing of the answer, println macro inside the block, we were okay, but when we put it outside, the compiler immediately saw, oh, that's not valid. So as you see here, the comment actually tells you the outer and the inner if you use something. So imagine that when the function was called, the this generic lifetime parameter a with the first trophy was actually replaced by the lifetime of inner score, and then by that the compiler was able to determine that your answer is no longer here, is not even there in this scope, right? So that's the idea behind lifetimes. It's a very easy way to making sure that, I mean, think about it. It's like if just as a joke, like imagine that you had the haunted spirit. Think of reference as a haunted spirit. So and the body as the thing that reference refers to, the object. So obviously you have to make sure that like you would not expect the haunted spirit of a human being live in an ant, because the ants have lifetimes of like few days. and the humans have the lifetime of years. So you obviously want to make sure that if you are a haunted spirit, you pick up a body which has a longer lifetime, maybe like an elephant. So if you are humans haunted spirit, so that's all there is. Basically, I would say the lifetime is just like this concept, making sure it's way of for compiler to figure out that references or handles point to things which are still living, rather than you try to use a handle after the object that it is pointing to or refers to as already freed. That's all is there in lifetimes. I hope it was a good introduction to lifetimes for you, and the lifetime annotation syntax, which is a little bit different from other languages. You haven't seen this lifetime annotations or the arguments being annotated with lifetimes in other languages, but you can pick up further concept related to lifetime from this general introduction to lifetimes in Rust. And I hope you guys all the best in your Rust adventures, and I'll see you guys in the next video. Bye bye.